Good day, class. In this video, we will continue the step-by-step demonstration of deriving the solution of the inverse kinematics of a given mechanical manipulator. Okay? So, the mechanical manipulator given is the spherical manipulator. Okay. So, just like the Cartesian and the cylindrical manipulator, we need the kinematic diagram of our manipulator and only its base frame. Okay, so this is its base frame. So we will redraw it again at top view and front view. Okay, so I will start again by redrawing it into top view. Okay, so this is the spherical manipulator at top view. Okay, again I rotated the manipulator counterclockwise so that we can produce a right triangle. Okay, so it also means that our theta 1 looks like a 45 degrees. Okay, 45 degrees rotated angle. Okay, but this is not exactly 45 degrees. I just did it so that we can have a right triangle. Okay, so this problem or this figure is much like the cylindrical manipulator's top view. Okay, so it means we will have the same solution for getting the theta 1. Okay, so from the end effector up to the base along the y sub 0 axis, we will have a y0 y03 given coordinate, okay, or given value for our position vector at y element or y coordinate. Okay, then from end effector up to the base along the x sub 0 axis, we have here the x04. Okay, the x03 given coordinate. Okay, so this coordinates will become the sides of our right triangle. So this is given, this is given. Okay, because y03 and x03 is given, we can solve for theta 1. So theta 1 using SOHCAHTOA and or the formula of tangent. Okay, so this is theta 1 is equals to inverse tangent of y03 over x03. So theta 1 is our joint variable. So we already have the solution for theta 1. Okay. So we will also number it as item number 1. So we will solve this first. Okay? Because it is already giving us the joint variable theta 1. Okay, next. So it almost looks like the top view of our cylindrical manipulator. This is the joint 2, this is the joint 3. Okay, the difference is the third joint is a prismatic joint, but it is connected across the the revolute joint perpendicular to our first joint, which is a twisting joint. Okay. So, based on the drawing and based on the solution for our cylindrical manipulator, it's easy to say that the solution here is Pythagorean theorem, where a2 plus a3 plus d3 is equals to square root of x03 squared plus y03 squared. Okay? It is easy to say based on our experience from the cylindrical manipulator. Okay? But it is not correct. Okay? It is not correct because this will not be our value of our hypotenuse. Okay, this is our hypotenuse because our hypotenuse is changing its length. Okay, because of the d sub 3. Okay, because of the d sub 3, our hypotenuse changes its length. Okay, this is a prismatic joint. This changes its length, as well as our joint 2 is a revolute joint. So it means that our joint 3 and the link 3 and the link before the end effector changes its orientation. Okay, changes its orientation. So it could be rotated clockwise downward or rotated counterclockwise to the left. Okay, this hypotenuse. Okay, with the third joint. So this is a top view. It looks like this drawing, but if we but in reality, okay, but in reality, this could be not the drawing. Okay, this could not be the drawing of the top view. Okay, a top view, if theta 1 is equals to negative 20 degrees, so it looks like it's just looks like this. Okay, okay, in reality, because this is a revolute joint. Okay, so instead of making our hypotenuse equals to a2 plus a3 plus d3, let's give a new name for our hypotenuse. Okay, so let's redraw here an arrow of our hypotenuse, and let's name it r sub 1. Okay, let's name it r sub 1. So r sub 1 will be the hypotenuse, or the value of the hypotenuse, or the variable of the hypotenuse. Okay, so because r sub 1 now is the hypotenuse, r sub 1 will be equals to square root of x03 squared plus y03 squared. Okay, so this is not yet a solution. Okay, this is not yet a solution because r sub 1 is not a joint variable. We still don't have a solution for d sub 3 and theta 2. Okay, we still have the solution for d sub 3 and theta 2. So we only solve the solution for theta 1, okay, at top view. But we will put the equation of r sub 1 inside a box. Okay, we'll still put it inside a box. Okay, next, let's go to the front view. Okay, at the front view, let's analyze it. At front view, we can only see the Z0 axis as well the X sub 0 axis. Okay. The X sub 0 axis. This is the X sub 0 axis. Okay. So, at the end, from the end effector up to the base along the Z0 axis, we have the Z03. So, this is our given coordinate. Okay. And also, along x sub 0 axis from the end effector up to base, we have the horizontal line, the x03. Okay? But we already used the x03 at our top view. So, here, we will not use the x03. What we will use in x03 is the value of r sub 1. Okay. So, our r sub 1 at top view is this at front view. This is our R sub 1 from top view. Okay. Because the link, this link, and the prismatic joint, and the link before the end effector, okay, changes its orientation if theta 2 has a value. Okay, so at top view it looks like this, but in reality it may not looks like this. Okay, so in front view, our r sub 1 from top view will be the horizontal line here, or the horizontal side here, while the hypotenuse is the a sub 2 plus a sub 3 plus d sub 3. Okay. Okay, so a sub 2 plus a sub 3 plus d sub 3. So another explanation is r sub 1 is changing its length. Okay, every time theta 2 changes its value. Okay, so we don't see it at top view, we can see it at front view. Okay, if this changes its orientation. Okay, so next is as you can see, there is a right triangle. Okay, there is a right triangle here, but this is Z03. We need to get the this part of the Z03, this upward part of Z03. Okay, so this upper part of Z03 will be named as R sub 2. We will redraw again. We will draw again a line, a gray line. Okay, this gray line will be R sub 2. But still, Z03 is from the end effector up to the base. Okay, now we have here a right triangle. Okay, this right triangle. Okay, so this right triangle, in this using this right triangle, we can now solve what is d sub 3 and theta 2. Okay, so we don't have yet the value for r sub 2. We can have the value of r sub 1 because of x03 and y03. So we can number this equation as equation number 2. Okay. Next, we have now r sub. We know how to get r sub 1. Let's find a way to get what is r sub 2. Okay? So based on this drawing, Z03 from the end effector to the base is equals to A sub 1 plus R sub 2. Okay? A sub 1 plus R sub 2. So if we arrange it, it is R sub 2 equals to Z03 minus A sub 1. Okay. So still not this is still not a solution to find the joint variable, but we need it for our right triangle. Okay, this is R sub 2. Z03 is given, A sub 1 is given. Okay. Okay. Next. Now we have the value for R sub 1 and R sub 2. We can all we can it is also safe to say that we can now find what is theta 2 using also the formula of tangent. Okay? So the formula of tangent is opposite over adjacent. Okay? So theta 2 is equals to inverse tangent, okay? Inverse tangent of R2 over R1. Okay, so we now have the solution for theta 2. Let's put it inside a box. Okay. And number it as our number 4 equation. Okay. So the number 4 equation, at the number 4 equation, we have now the joint variable theta 2. So our only problem is the joint variable d sub 3. So to find the joint variable d sub 3, we will use the Pythagorean theorem. Okay. So we have here a sub 2 plus a sub 3 plus d sub 3. Okay. Is equals to the square root of R1 squared plus R2 squared. Okay, this is square root. Okay. What we need is the d sub 3. So we will square both sides. We will square both sides so that we can equate all of them to d sub 3. Okay, so that we can apply the rules of algebra if we remove first the radical sign. Okay. So this will become like this. Okay. Or it's almost like that. Okay. So it will looks like this. Then uh then uh so this is squared. Okay. We can remove the we can what do you call this? Oh, we don't need to square both sides. Sorry, we don't need to square both sides. What we need to do is uh just add both sides negative a2 plus a3. Okay, we will just add both sides negative a2 negative or we will subtract both sides of minus a2 and minus a3. Okay, so it will look like this. Don't need to square, sorry. Don't need to square. Okay. So d sub 3 is equals to square root of r1 squared plus r2 squared minus a2 minus a3. So d sub 3 is the joint variable. Let's put them inside a box. Okay, and number it as our fifth equation. Okay, so at our fifth equation, we can now solve the d sub 3. So we have 5 equations for our spherical manipulators inverse kinematics. Okay, so summary. Okay, so to solve for theta 1, we use the inverse tangent because y03 and x03 is given. Okay, then we can use a sub 2 plus a sub 3 plus d3 as our hypotenuse. That's why we name our hypotenuse r sub 1. Okay, so that's for top view. At front view, okay, the r sub 1 is the length of this link, okay, link of the prismatic joint and the link of the end effector that changes if the link or theta 2 changes its orientation. Okay, then we can now give the value for this links a2 plus a3 plus d3. Okay, then we have here a new side which is r sub 2, so that we could get uh get the value of it from the z03. So r sub 2 is equals to z03 minus a sub 1. Okay, then because we know now how to solve for r1 and r2, we can solve for theta 2 using the tangent formula again. Okay, so at equation 4 we have theta 2. Then to solve for d sub 3, okay, we will use the Pythagorean theorem. Okay, we'll use the Pythagorean theorem. Oh, I forgot. I'm correct. We need to square this. Okay, because Pythagorean theorem, okay, Pythagorean theorem looks like this. Okay, Pythagorean theorem looks like this. Okay, this is Pythagorean theorem. Okay. This is Pythagorean theorem. Okay, this is Pythagorean theorem. Then square both sides, not square root both sides. Okay, we should square root both sides so that we can we can apply the rules of algebra to subtract both sides by 8.2 and 8.3. Okay. So this is the Pythagorean theorem. Square root both sides. Okay, then arrange the equation. So we have d3 equals to square root r1 squared plus r2 squared. Then next is minus a2 minus a3. Okay. So this is the solution for the inverse kinematics of spherical manipulator using the graphical method. Okay. Thank you.